Okay, so we're in activity 3.3, exploring inverses of quadratics. You've determined inverses of linear functions by reflecting a function across the y equals x line. Consider the basic quadratic function f of x equals x squared. Reflect f of x across the line y equals x. So first off, let's identify the y equals x. Okay, which is right here. This is your y equals x line. Okay. Now, let's find the values for x squared this here. So that'd be -2 squared, which is 4, -1 squared, which is 1, 0 squared, which is 0, 1 squared, which is 1, and 2 squared, which is 4. So let's go ahead and graph those points. So -2, 4. Okay. -1, 1, 0, 0, 1, 1, 2, 4. Okay, let's go ahead and graph this in pink. Okay. Now, for the inverse, very simple. All you have to do is switch these values. So this becomes 4, 1, 0, 1, 4. This becomes -2, -1, 0, 1, 2. So let's go ahead and graph those points. So in 4, -2, 1, -1, 0, 0, 1, oh, 1, -1, 0, 0, 1, 1, and 4, 2. Okay, go ahead and finish up the graph. All right, let's take a look here. Okay, explain why the inverse is not a function based on the graph. The inverse is not a function because it does not pass the vertical line test. So when I draw, and let's do the vertical line test in a different color. Let's do the vertical line test in green. Okay, so when I draw a vertical line through this graph, it crosses once and twice. So this is not a function. Okay. All right. Now, what is the domain and range of the function? What is the domain and range of the inverse function? So the domain of f of x is all real numbers because from left to right, it just keeps going infinitely. Okay. Now the range starts at 0 and it goes up. So it's y greater than or equal to 0. Okay. Now let's take a look at the inverse for the, and then just like the x and y values, the domain and range switch. So the range is now x greater than or equal to 0, and the range is all real numbers. Remember, domain is x, range is y. Okay. All right, let's take a look at the next part. You can determine the equation inverse of the basic quadratic function f of x equals x squared the same way you determine the equation of the inverse of the linear function. Okay. So step 1, we replace f of x with y. So we have y equals x squared. Step 2, switch x and y. So x equals y squared. And then we solve for y. So we take the square root plus or minus of both sides. Now, the square root cancels the squared, so the inverse is plus or minus square root of x equals y. So the equation of the inverse is y equals plus or minus the square root of x. Explain why the inverse is not a function based on its equation. The inverse is not a function because the square root of a number can have two values, the positive square root and the negative square root. Okay, go ahead and finish that up. All right, let's take a look at the next page. All right, you know that the inverse of f of x equals x squared is not a function. However, you can restrict the domain of this function so that the inverse is also a function. To restrict the domain of a function means to define a new domain of the function as a subset of the original domain. Consider the graph of f of x equals x squared and the graphs of the two equations that it represents inverse. Identify the restrictions of f of x equals x squared to produce the inverse equation of y equals square root of x and y equals negative square root of x. Then state the domain and range of each. So the domain would be x greater than or equal to 0, y greater than or equal to 0. And the domain would be x greater than or equal to 0 and y greater than or equal to the positive inverse. Okay? Now, the domain of x squared is still the same here. Well, x is greater than or equal to 0, y greater than or equal to 0. But now, because this is negative, the y is less than or equal to 0. All right, so go ahead and finish that up. How does the domain and range of the inverse relate to the restricted domain and range of the function? The domain and range of the inverse are the reverse of the domain and range of the original function. All right, let's take a look at the next page. Activity 3.4, more with inverses of quadratics. Immerses competing in egg drop competition at a school science fair competition. Using an egg drop competition are required to create a container in which they place a raw egg and then drop the container from various heights to see if the eggs break. The winner of the contest is the person whose container and dropped it from the roof of a building. The height of the egg can be modeled by the function f of x equals negative 16x squared plus 64, where x represents the time in seconds. Define the independent and dependent quantities of fx. The independent quantity is the time in seconds. The dependent quantity is the height of the egg in feet. All right, so let's go ahead and graph this. Okay, so to do that, let's go to Desmos. Okay, we're going to graph negative 16x squared plus 64. And we're going to adjust the window. So we're going to go here. We're going to go from 0 to 5, or sorry, 3, and 0 to 64. Okay, and then here we go. We might zoom out just a hair. Okay, now we need points to graph. I suspect this point's good. This point's good. And 2, 0. Okay, and then there's our graph. Now, the domain and range. The domain goes from here to here. So domain would be 0 less than or equal to t, but we're using x. This actually should be x and f of x. Less than x, less than or equal to 2. So basically the egg was in the air from 0 to 2. Okay? Then the range would go from 0 to 64. That's the range of the height. Okay? So the range is 0 less than or equal to f of x less than or equal to 64. Determine any restrictions on the domain of f of x based on this problem situation. Explain your reasoning. Based on the problem situation, the domain must be 0 less than or equal to x less than or equal to 2 because the egg was dropped after 0 seconds and landed at 2 seconds. Range must be between 0 less than or equal to f of x less than or equal to 64 because the egg was dropped from 64 feet and hit the ground. Okay, go ahead and finish it up. All right, let's take a look at the next page. Graph f of x equals negative 16x squared plus 64 with the restricted domain based on a problem situation, which we did on the previous page. So let's just do that again. 0, 64, 1, 48, and 2, 0. Okay. Now, define the independent variable conjugate for the inverse. So all we have to do is switch. So this becomes 64, 48, 0, and this becomes 0, 1, 2. All right, go ahead and finish that part up. All right, now the domain of range, zoom out a little bit. The domain goes from 0 to 2. So, oh wait, I'm sorry, of the inverse. So now we're talking about this. So the domain of range goes from 0 to 64. And the range now goes from 0 to 2. Okay. Now, to graph the inverse, we're going to use these values, okay? So 64, 0, 48, 1, and 0, 2. All right, go ahead and finish that up. All right, let's take a look at the next page. Determine the inverse of the function f of x equals negative 16x squared plus 64. Okay, so step 1, we change f of x to y. Step 2, we switch x and y. And step 3, we solve. So we're going to subtract 64 from both sides. Get x minus 64 equals negative 16 y squared. We're going to divide both sides by negative 16. So that divided becomes 1. We're left with x minus 64 divided by negative 16 equals y squared. And then the last step, we take the square root of both sides. Well, the square root cancels the squared. Okay, explain what the inverse models in terms of the problem situation. The inverse of the function models the time that the egg is in the air in seconds based on its height. After 1.5 seconds, what is the egg's height? Explain. So we're going to basically plug 1.5 into this function. Okay, so we're going to go to Desmos. Okay, and actually let's just go to desmos.com. Math tools, scientific calculator, -16, parentheses 1.5 squared plus 64 is 28. So the height of the egg after 1.5 seconds is 28 feet. Okay, now 11. After how many seconds is the egg at a height of 55 feet? Explain which function you use and how you determine the answer. So we're now going to use the inverse function. So in this case, x is 55. And so we're going to plug 55 into the function. Okay, so let's delete this. Square root of divide 64 minus 55 divided by -16. Oh, I just caught. Sometimes this happens. This equation is actually incorrect. So let me just fix that. I just noticed it's supposed to be x minus 64. So if that ever happens, double check your work like I just did. And let's fix. Okay. So now, easy fix. 55 minus 64 is 0.75. Okay. So the egg's height is 55 feet at 0.75 seconds. All right, go ahead and finish it up and have a wonderful Wildcat day.